Good day, everyone. My topic is advances in aquaculture, improvement for salmon trout. Aquaculture, the Chilean situation and prospect. First is first development for the genetic improvements in aquaculture. So, salmon trout farming in Chile started in 1986 with a production of 2,500 tons and increased to about 200 tons 200,000 tons in 1996 and 647,000 to 263 tons in 2006 and to 727,000 to 810 tons in 2016. The production started with a coho salmon and industry growth has been based on Atlantic salmon. So, which is currently exceeding to 70% of total salmon and trout production in China, and is currently the second largest producer of salmon and trout in the worldwide, which position the country as uh, one of the top 10 exporters of the fish products. Next is genetic improvements in salmon and trout. Um, First is step of the bioeconomic analysis approach to estimate marginal economic value for salmon breeding programs and productive environment and economic data from company or the industry are used to build environmental, management, biotechnological, and economic submodels. So using this system approach and including stochasticity, some models are integrated to bioeconomic model that variables. Productive until size, basic parameters of the productive system and restriction of operation are defined to run simulation using bioeconomic model. So using this uh, 2000 simulation, a probabilistic economic benefit function per fish, so which includes the traits into the breeding goal is estimated and multiple regression of is calculated than applying partial deviation. Aquaculture commidities. So my aquaculture commidities is Atlantic salmon. Their scientific name is Salmosalar. Mm, And next is genetic parameters and response to selection. So you see the table one, we have three species of salmon. The Atlantic salmon and coho salmon, and the last one is rainbow trout. Ay, hindi pala yun. So this one is a percentage of genetic gain for growth measured as a harvest weight in salmon and trout breeding programs in different countries. So genetic parameters and response to selection. Growth is the main breeding objective in salmonids. The main selection trait is weight at harvest, which in the Chilean production context is negative negative 3 kilogram in coho salmon and rainbow trout. And in Atlantic salmon selection responses have been reported for being programs around the world in all three species for weight. So at harvest, genetic gains achieved are 10% per generation. To date, there is a there is a little information on the response to selection for carcass quality traits. For instance, selection response in fat content has been reported for the rainbow trout harvested pan size. So 260 grams uh, through specific selection trials for created high and low fat lines and after two generation of selection. Next is structure of the Chilean salmon and trout egg market. Uh, by 2010, by 2010, we have 32 breeding programs had been established for salmonids worldwide. This situation has resulted in that for instant, 97% of the worldwide production of Atlantic salmon is um, is currently based on genetically improvement stock by Chile plays a key role in the international salmon market, and selective breeding is considered an important tool in increasing the competitiveness of Chilean aquaculture. So, the Coho Salmon breeding program is established by IFOP. So, and the Universidad de Chile in 1992 was created to establish a centralized breeding program to supply the industry with a genetically improved broodstock. So after this early initiative, the rapid growth of the Chilean salmon industry has led to the establishment of about 15 private breeding programs for salmonid species. So in the country, uh, representing almost half of the total number of salmon and trout breeding program in the world. Next is future challenge and opportunities. So the first is climate change. It is expected that in the near future, climate change will affect aquaculture via various external factors, including emergence of a new disease, frequency and severity of weather events. So the seawater acidification, rising sea level, and change in water temperature, and the current stock used for salmon and trout culture may not be may not may not be optimal in future conditions. So, for instance, we have salmonids are poikilo poikiladder poikiladder mite organism, which make them highly sensitive to extreme change in water temperature. Uh, so we have a strong GXE in growth of rainbow trout, reared reared in different temperature has been reported. So the resulting in a substantial ranking of breeding candidates, we have a we have a however we have the way climate change will alter the production environment is difficult to predict. So it's unlikely that current selection will enable anticipating all future challenges. And the second is demonstration of added value. One of the important challenge for supplies of eggs from genetically improved broodstock is to demonstrate that their customer will increase profits through the superior performance of their fish. So, will design performance test provide a benchmark allowing short term. So, the product validation and the means to compare genetically improved products from different supplies and review several benchmarking studies of conduction. So, on fish at the global level, while statistically solid, they are all experimental and studied. On a small scale, benchmarking like a initiative should be implemented on a commercial scale to allow more realistic economical uh, appraisal. Because of the performance of genetically improved fish can vary significantly to due to difference in environmental and management factors. So it is difficult to infer performance based on data obtained under commercial conditions. And a good alternative to evaluate genetically improved stocks at a production scale is a bioeconomic approach which can manage stochastic variation and have been used for the economic evolution of technological developments. And the third is research and development. Rapid, 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 rapid technological advances in genomics have allowed improvements in selective breeding approach during the last decade. So, for instance, GS increased selection accuracy compared to traditional pedigree-based selection in salmon. So, although there is now published information about objective economical appraisal of the implementation of GS. So GS is in aquaculture breeding programs, the development and implementation of affected genotype amputation strategies will promote the establishment of cost effective GS for traits that are difficult to measure in selection candidates. So, moreover, the identification of functional causative variants is also called quantitative the quantitative traits nucleotides. So, will maximize genomic prediction accuracies within and across population, decreasing the need to obtain phenotype for each generation and population. And the last one is market share direction. So the large economic investment in breeding programs to incorporate genomic, which tools and set up inland facilities, have been required to ensure the high quality of eggs from improved strains. So this investment push the industry to the consolidation of specialized eggs supplies with high volumes of production. So where the cost of egg is highly diluted, the customers will notice the increased value of the eggs and will learn that to expect from the egg supplier in terms of product quality and performance expectation. It is expected that selection indices should be adapted and customized to each potential egg buyer to reflect their specific requirements. So for these reasons, strong technical assistant teams should be developed within each egg supplier company. So as a case, the most important livestock genetic companies, uh, Newman, this is this will ensure that the value added by genetic improvement is reflected in production. Those technical assistants will become a strong commercial tool and will be help to differentiate suppliers of improvements of the eggs. So the development of benchmarking programs is essential to demonstrate added value aspects such as feed conversion efficiency and the high temperature um, the high temperature is tolerance should be accounted for by genetic improvement companies. And that's all. Thank you for